Hey, welcome to the first episode of Ultra Modular Interaction and Inventory System in Unreal Engine. It's a series that I wanted to start and go over how to conceptualize, think about, and actually create a system like an interaction system or an inventory system, something that will be embedded in your game pretty much at any level. If those systems exist at all, they're kind of going to be embedded pretty deep within the fabric of your game. And there's not many deep tutorials on YouTube going over how to think about these things or how to implement them in a modular, scalable way. So I wanted to take a crack at it, and I think we'll be able to come up with something that hopefully is the last interaction slash inventory system framework you'll ever need to create, and we can just use it on any project in the future, and it'll be a starting point. It's going to be kind of an advanced series or episode, but I don't think it's out the realm of possibility for a complete beginner to follow along and learn something. But I won't be going into the absolute basics. I'm going to assume you have a like very beginner understanding of things like interfaces and components and stuff like that. So without further ado, let's first talk about how we want to think about these kind of things. So an interaction system, what is an interaction system? And the only reason I'm really thinking about an interaction system is because I'm after an inventory system. And the first thing that comes to my mind when I think about an inventory system is I need to be able to pick things up off the ground. And so if I think about an interaction system, what is an interaction system? An interaction system is basically a system where there's a prompt, the player needs to input something, and something will happen. You will interact with an object by first pressing an input or walking over it or something like that. Now, what else is there to it? Well, we don't want the player to be able to just press the input and be able to interact with something 100 million miles away. We want it to happen at a certain radius. And we also don't just want an interaction system that will cover just picking up items off the floor. We would like an interaction system that can scale with our needs, as far as you may want certain events to happen when a player presses the input and interacts with something. You may want a UI to pop up. And we would like to create a system that not only will fit our needs for the inventory system, but also that we can expand upon without that much of a hindrance and implement all the interaction needs of our game. And so with that, and in the context of thinking that this will be hopefully the last interaction system you make, slash inventory system you make, it's going to be a little unorthodox how I do things, because I want to come at it from the aspect of that this is a new project. You don't have any kind of file or hierarchy or inheritance that you can pull from. These are just a bunch of random blueprints that you would like to be able to interact with. So with that in mind, let's get started. And quick note before we get started, I've realized this in editing that I didn't make it quite clear that this is not meant to, like, if you're building or trying to add this, I wouldn't expand on what we built today. The point of this basically is to start a fresh project. At least that's how I like to do it, is start projects to specifically build the systems, and then as needed, migrate those systems out to new projects or to other projects. We don't want to spend all this time building something that we can use on every project and then customize it, customize that one file to fit only a certain project. So we want to make sure and I'll go over how to do that specifically in the next episode or the episode after that. But I just wanted to put that in here to preemptively stop someone from maybe, kind of working backwards by specifically customizing a system that we're trying to build to be generic, trying to customize it for something very specific. So this is I have open, if my mouse will move, I have open a fresh, this is just the default template for the third person. It's the third person template default for Unreal Engine 5.4. And the first thing I want to do is go into the content browser, and I'm going to create a new folder within content, and I'm going to call it Ultra Modular Int and In System. Yeah, and what a name. I'm also going to change the color just so I can notice it a little better. And by the way, this probably will get kind of long, but at the end of it, the framework will be built out that we can expand on this and dive deeper and deeper and deeper. And by the end of it, I'm hoping to turn this into a whole game, maybe like an RPG, like a Valheim type game or something like that, And once we tackle the interaction system and the inventory system, we can move on to things like AI, combat and really practice our conceptualization skills as far as these deep, intermediate slash advanced systems. Okay, so I have our folder that's going to serve as the root for everything we're going to do. And if my mouse will come back. All right, cool. So I'm going to right click in there and I'm going to create a folder called blueprints. And then I'm going to right click and go to blueprint class, create a actor. And I'm just going to call it BP test item caret. I'm going to call it BP test item mushroom, BP test item, I don't know, steamed veggies. And these are the three completely different blueprints. Like I just created a new one and duplicated it twice. So they do not inherit from anything. There's nothing tied to these blueprints. These are just completely random. I'm gonna create a folder in here called test items. And I'm gonna drag those in. Cool. And then let's actually create a new level and go to basic. And then we can file, save current level as, and in our main folder, create a folder for levels. L testing. Cool. And then within our main folder again, let's right click, create another folder called meshes, create another folder called textures. And in the description for this video, I'm going to have a link to this website. This is a great free asset website. And within the assets, in the 3D section, you can go to this food kit. And this is just like FBXs of this food kit, but it comes with preview PNGs that we can use as icons. So that's what we're going to do. We're going to just use those, just one kit for our testing purposes and do that. And so in the meshes folder, I'm going to create one called food kit. And inside the food kit, I'm going to find that food kit that I downloaded that I just showed you. I'm going to select all the FBXs and drag them in. Bam. And these are the static meshes we'll be using. And in the textures folder and the icons folder I created within the food kit folder, if you downloaded that same pack, there's a bunch of preview images and we can just drag those in. There we go. And so now we got some icons. I'm going to save all real quick, but now we got some icons and some meshes that we can use to test things out. All right, so the next thing I'm going to do is go up to edit project settings and I'm going to implement some gameplay tags. Now, if you're not familiar with gameplay tags, they are very similar to enumerations, but they are hierarchical in nature and I have found them to be exponentially more useful than something like an enumeration. And it may not be abundantly clear why that is at first, but as we get deeper into this system, you'll see the potential and the power of gameplay tags, and you'll probably, like me, you'll use them on everything after that. So if you, in your project settings, in the left, if you go to gameplay tags, you can hit this button, manage gameplay tags, hit the plus button, and right where this says source, you'll need to change that to the default gameplay tags INI, and then you will be able to add your own gameplay tags. And they are, you see how it says x.y.z, and basically it's a bulleted list, and every time you hit a period, it'll indent the list, the bulleted list. It'll indent and make another subcategory. So we're gonna go. I usually call anything that can be interacted with in the game a game item, but you can do this however you want. For instance, you could just put item. I'm just gonna put. Well, let's just do that. Let's keep modularity in mind and put item, because these are the test gameplay tags that we'll be creating in this project, just so we can actually build and use the system. But in your own project, you'll probably not import the few that I'm going to create here. You'll actually just create your own. And moving forward, when you migrate this to other projects, you'll probably just create your own. So I'm going to create one. I'm going to type item, press period. I'm going to say consumable, and then press period again. I'm going to go food, period. This is just to illustrate that how, like, you can have subcategories of things in gameplay tags. And then I'm going to type period after food, and then I'm going to type mushroom. And if I hit enter, you see we not only have the mushroom, we have what kind of food it is, what kind of consumable it is, and the fact that it's an item. Now, if this was just an enumeration with the word mushroom in it, anything that uses that would just know that it's a mushroom. Using gameplay tags, it now knows that it's a food, it's a consumable, it's an item. And hopefully that kind of illustrates how powerful this can be. Um, and let's actually right click on food and we can create another subtag for, I think it was carrot. And then we can right click on consumable and type meal and then type steamed veggies. And those are the 3 items we'll work with today, just to illustrate the point. And you can see now we have an item gameplay tag, but with a drop down and then we have a consumable category, food, meal, and all the individual ones. Let's do that. Boom. And now I'm also going to create some events, I guess you could say. So we can say event interaction destroy after interaction, and add a subtag to interaction. And we can go event interaction add to inventory. And this we're actually going to use to dictate what happens on individual items, what happens to them when we interact with them. So we can make a long list of interaction events, and basically we're just going to call one event when we want to interact with something, and based on the tag that they implement for that blueprint, we can determine what happens on that specific blueprint. I know that might not make a lot of sense, but it's a very similar system to what they would use in the gameplay ability system that Unreal Engine has, and we're going to try to put that same philosophy to use. Okay, cool. And so the next thing I think we should do is in our blueprints folder, we can right click and create a data folder. And in that data folder, we can go to blueprint class and type in primary and get this primary data asset. And we will say item primary data asset. Cool. And this is going to be basically what we're going to use to store all the data that is relevant to each item. And for our purposes, it'll be under the context of like an inventory item, but you can really go as far as you want with this. And if you've never used data assets before, they're very similar to structures, except they are an object class and it's in and of itself, and they can have functions, and they have no world context, but I mean, they can have macros, functions, event dispatchers, everything. So they are very powerful. And we're going to, in a few minutes, we're going to get into a way that most people, most tutorials that you'll see with things like data assets and structures, any form of data will actually cache or like make variables of that data all over their project. Like for instance, if this data asset, it represents an item, most people will need to put that variable in the blueprint, in any kind of UI, any kind of components. I mean, by the end of the project, they'll have the same data about a certain item 10 times over, all over their project. And it's really important when developing complex systems to try to maintain a single source of truth. So instead of passing this variable to all kind of different blueprints and, maybe it changes somehow accidentally, and now, all the variables and all the different blueprints are not in sync, and it'd be much better to have a data table that we can reference and get the data for anything in the game, and it's all in one place. And using data assets and gameplay tags, we can actually do that without ever really creating a variable. And we're going to get into that now. So I'm going to actually, let's go back into our data folder and create another folder for enums. And we're going to need to create an enumeration for the name of the item. And I'm not just going to put item name. I'm going to put external item name. That way we know that it is player facing. For instance, internally you might have a different name for an item, but externally, like what the player will see, this is what that'll be. Mushroom, carrot, steamed veggies. And the reason why we're not just using the gameplay tag system for this is I haven't really found a way to get a usable name from the gameplay tags. Like you can get the actual text that the gameplay tag is, but it's going to come in like item.food. It's not, and you can't have spaces in gameplay tags. In enumerations, you can have spaces. So it works really well for stuff you want to make neat and display to the player. So, and I always create a backslash for the first thing in a first slot in an enumeration, because that really seems, having something there that you'll never change on the first one seems to create a lot less bugs in Unreal Engine. So I typically try to do that. And back within our item primary data asset, we just need to think about all the data we will need for items in order to properly translate that data on screen in the form of an inventory. So we're going to say item name. I'm going to make a variable for item name. I'm going to get that enumeration we just created. I'm going to create another variable, and I'm going to search for of type gameplay tag, and I'm going to put item tag. And we're not going to have any like property tags. Well, I guess we will. Yeah, we can have property tags, or actually let's call it event tag or interaction event tag. And we'll just leave that as a gameplay tag. But you can do many things with gameplay tags, and we'll dive into all of it. If it's not extremely apparent how powerful they can be, just give it a little bit. And as we dive deeper, you'll see that they are really something that is so underrated. I can't even. They are probably the most underrated thing about Unreal Engine. Okay, and so we have the item name, the item tag, the interaction event tag, which is basically going to associate what interaction event should happen for every individual item. The next thing we can think of, we're going to need is an actor class, just in case we want to spawn that item. So we can say item class, and then we can say, we can say max stack size, or item, since I've started I haven't. Yeah, okay, max stack size. There we go. And just in case, we can actually put, just in case it's a purchasable or something, we can put base purchase price, duplicate that, base purchase, or base sale price, sure. Why not? And you can really put whatever variables you want in here, and you can add to them at any time, really. So we're going to go texture 2D, and that's going to be our icon. I'm going to drag that up with all our item stuff. Oops. And then we can create one more, which is, I think will be the last one we need, which is going to be a static mesh. Item mesh. Cool. And that should be it for now, I believe. The next thing we're going to do is go into our data folder and create another folder for structures. Go into that folder, right click and create a structure, and we're going to call it S item data sort. We're going to go into that, and we're going to create two variables, one of type gameplay tag that I'm going to call item tag, and the next one of type, it was item, no, yeah, there it is, item primary data asset. So two variables, one is the item tag, and one is a data asset a reference to the data asset object we just made. So item data asset. Cool. And then in our data folder, we will right click, and under miscellaneous data table, we'll create a data table, and we'll select the structure we just made, item data sort, and we'll call it DT item data sort. Boom. We'll open that up and we'll create a couple rows. Now the row names do not matter really for this context. We're just going to want to associate every item gameplay tag that we have with a data asset, with the item primary data asset that goes to that blueprint. So inside of our data folder, let's create a folder for assets. Let's just call it assets. Go in there, and if we right click under miscellaneous, we can create a data asset, and we can just find our item primary data asset. And we can say item data underscore carrot, duplicate that, underscore mushroom, duplicate that, underscore steamed veggies. Cool. And let's jump back into our item primary data asset real quick and just check some of these. And yeah, let's make some default values for these. So interaction event tag, we're going to want add to inventory. Actually, let's go interaction event tag. Let's make that a gameplay tag container. So, and change it to interaction event tags, because we're going to want to do both of these things. And you may want to do multiple things in your game. Let's make the max stack size 50, the base purchase price 50, and the base sell price 25. And I put base price on both of those just in case. In most cases, you're going to want to add a multiplier to you're going to want to have like a value that represents just the base price and then add multipliers to it. And so setting it up like that, it's a good way to do that. Just having the base value that represents it. And then if we go into our assets, let's open up the item data caret, and we can select its name, select its item tag, and select its class caret. And in the item mesh, we have caret. This is from that the food kit we downloaded. And then in the icon, we should be able to type caret. And then we have those already set. Let's jump back into our item primary data asset and make a variable of type transform and put offset transform. And usually in the food kit, the meshes come in a little small. So I'm just putting this here to scale everything up a little bit so we can see it a little better. So we have the item caret. You can skip ahead, but I'm going to just fill out all this information real quick in each one of the data assets. And in the item class variable, I'm just searching for those random blueprints we made at the beginning to test the items, basically, to test what we're doing, All right, so mushroom, cool. Should be mushroom. And then we have that. Cool. And then what's the other one is steamed veggies, looks like. And test steamed veggies. And in the Kenny kit, there should be just a plate dinner. Plate. Which one? That looks like this one. Yeah, cool. Got it. All right, cool. And that's all the data we're going to need. Now we can jump into our data table and fill these out. So for the caret, it's the caret. For the mushroom, it's the mushroom. For the steamed veggies, it's the steamed veggies. And then in our blueprints folder, we can create a folder called game. Right click, go up to blueprint, and we'll create a blueprint function library, and we'll call it my BPFL for my blueprint function library. Let's create a new function called get item data by tag, and we'll add an input to it of type gameplay tag, and we will call it item tag. Cool. And then we'll right click and get all data table, right click and type get data table row names. And then we can find our item data sort. We will do a for each loop with break over all these rows that are coming up in this data table. And we will right click and get data table row all the way at the bottom. Select our same data table, connect these and break this structure. And if the row is found that matches the item tag we are searching for, we want to return this data. So we want to pull off an item tag and type matches tag. We want an exact match. And we want this variable here, this input variable, but we can just type get item tag, and that's going to be this right here. And then we can connect that. We can, if it's true, we want to promote this to a variable for a local variable, but then just disconnect it. And I'm going to change it to found data ? And then I like to put parentheses in all my local variables just so I can differentiate them. And so if these tags match, yes, we have found the data, and we will promote the found data asset. We'll promote that to a variable as well. And then we will break out of the loop. Because once we have found what we're looking for, we really don't want to waste any cycles like looping over this when we've already found what we're looking for. So if it finds what it's looking for, it's going to stop looping and then just exit the function. And in which case, when it exits the function, it's going to give us the data that we saved here. So after completed, we can get a return node and Just plug these in. And this should be able to be a pure function as well. Pure. Boom. And now we have that. And if we go into our blueprints, test items, let's pull up caret. And you'll be able to see the power of this in just a second. So under variables, let's create a gameplay tag variable. And we'll call it item tag. And we'll make that instance editable just in case. And we'll make another variable called of type integer called item quantity. And the reason, and actually let's expose this item quantity. Let's expose it on spawn as well and make it instance editable. And you would think that you would put the item quantity within this data asset, but typically you're going to want to separate the quantity of an item by the instance of that item in the world. So this instance of a caret, you're gonna want to probably be able to set this quantity to 5 and this quantity to 10. Or for instance, if you dynamically spawn an instance of this caret, you're going to want to set the quantity right then when you spawn it. And if we tied the quantity to this data asset, we would have to create a data asset for every quantity we wanted, basically, or change that variable every time. And I find it much better to just do it inside the actual blueprint. And I'm just going to put 5 for now. And then now typically in a game, you'll have some kind of file hierarchy, and you know, we would probably only need to do what we're about to do to all 3 of these test blueprints to one blueprint, and then the other blueprints would inherit from that blueprint. But I'm just doing it this way to illustrate that this will work in many different scenarios, you know, in many different games. So let's add a static mesh to this blueprint, and we're going to call it item mesh. And let's in the construction script, we can right click and type get game. What was it? Get item data. Yeah, here we go. Get item data by tag. And we'll punch that in and then connect this to a branch. And this is the data that represents this item that we're in. And we didn't have to create a variable, save a variable, check anything but this. And anywhere in the project, we will be able to do this as long as we have the item tag for what we're looking for. So now we have this item mesh right here. We can just pull out and type set static mesh. And we will be able to get the mesh and set it. Boom. And then while we're here, let's get we had an offset transform. And so we can get our item mesh and we can get world scale. And we can just multiply it by this scale that we set up in the offset. Boom. And then we can get this item mesh again and set world scale. And we can actually add a branch right here because we really only want to do that if it was actually set to something. And I'm just going to, since this is all like basically off a blueprint function, we can just copy this. I mean, it's from a blueprint function library. We can basically just copy this, add a static mesh to these blueprints, go into the construction script and just do the exact same thing. Oh, it needs the item tag. And like I said, I'm doing it with these 3 completely random blueprints just to illustrate that pretty much any blueprint in your project, as long as you create an item tag and an item quantity, or basically just an item tag, you can pull data from it and from anywhere in your project, basically, even if it's not like optimally set up, so to speak. Variables, gameplay tag, duplicates item quantity, integer, make that expose on spawn, create a static mesh, call it item mesh, and we will plug this in. Boom. That should be good. And I'm just making sure all these 3 compiled correctly. And we should be able to, let's see. No, what's going on with that? Did we not set the data thing? Oh, we didn't set the blue. You have to set the blue item tag in the actual blueprint as well. So in this item tag in the carrot blueprint, we're going to go carrot. We're going to click this, go mushroom. Click this. We're going to go steamed veggies. There we go. And if we did I delete them? Yeah. So here we go. Yeah, we have a carrot. Now they're a little big because of the scale that we added to the data asset, the scale offset, which we can actually bring that down a little bit maybe. But there we go. And these are going to be the test items that we use moving forward. Okay, so, and actually now that we hit play on this, you can see that this item just floats in the air. So let's go into our blueprint function library and create another blueprint function called update physics, or actually update item physics. Let's create an input for a primitive component. And then create another input for simulate question mark. And before we do that, let's go to edit project settings and go down to collision. And they have these presets for the for all the like collision profiles. So let's actually create a trace channel, set its default response to ignore. Or actually let's create a let's do that trace channel and call it interactable and hit accept. And in this physics actor profile, let's change that to block the interactable one and ignore the pawn one and hit accept and then save. And we can go into our blueprint function library in the update item physics. We can drag off the primitive component and type in set simulate physics and connect that to simulate. And then we can drag off the primitive component again and type set collision enabled. And off of the new type, we can type select and we can type get simulate, which remember is just this variable right there. And if we are simulating, we want to change the simulation, the collision to collision enabled. And if we are not, we want to change it to no collision. And lastly, if we drag off of here, we can type set collision profile name, connect that, and do a select off of the in collision name. And we're going to get the same simulate variable and plug it in. And if we are simulating, we want the profile to be the physics actor profile. And if we are not simulating, we want it to be no collision. And just like our other function, we can call this from basically anywhere in the project and update the physics on one of our items. So on event begin play, we can just type update physics, update item physics, and plug that in. We can type simulate yes, and item mesh, we plug that in. And the reason I'm doing it this way is because they're like for items that you interact with, I'm just thinking about equipment, stuff like that. Otherwise, we would just set it up to simulate physics once and be done with it. But in some cases, you may want to spawn an item or equip an item and it not simulate physics. So it's better to set it up this way, and you can always just disable it. Like you can create a function in here called onEquip and call this function in the item and turn off the simulating physics, for instance. And the whole goal of this whole thing is to create an extremely ultra modular and scalable setup. So keeping these things in mind goes a long way. And now if we go to, there we go, it falls. All right, cool. So now our items have physics when they spawn by default, and we can always just turn that off as needed. And real quick, I'm realizing that I have to click to get control of the screen. And if we go up, hit these three buttons and go to advanced settings, I'm going to pull this from my other window. You'll get this menu, and at the top, game gets mouse control. You can just click that, and you won't have to click anymore to get control of the editor. There we go. And I'm just going to, I don't know why I put those behind me, but I'm going to put them to where we spawn and we can see them. There we go. Cool. And they're still a little big, but it's kind of funny. All right, cool. So let's go to the ultra modular enter or int and env system and create a new folder and call it components. And we will create a blueprint class of type actor. And this is basically, oh, not actor, I'm sorry. Right click and blueprint class of type actor component and call it item container component. And this is going to be the master component that we're going to use for any, and it's an actor component. So it's a container that we can attach to any actor that has an inventory associated with it, basically. And by creating childs of this component, we can implement different, like slightly different functionality, but at the heart, it all has the same few functions and implementation that all of them will need, if that makes sense. Let's duplicate that and name it interaction manager component. Cool. And while I'm thinking about it, before I forget, let's go into blueprints. No, let's go into the third person folder that comes with the template. Go into blueprints, go to third person character, and let's just add these to our character. Add interaction manager component and item container component. And we can add an input while we're here for IA interact. In the third person folder that comes with the template, go into actions, or that go into the input folder, go into actions, and then I just duplicated jump and created and just renamed it IA interact. Then in the input folder, you can go into the default, drop down the mappings, and add a new mapping for interact. Hit that drop down, click on that, and press E, and that'll give us an interact key, basically. Okay, cool. So now let's go into our components folder we just created and open up our interaction manager. Now this component will serve as the manager that basically will interpret what we're trying to interact with and send out that data or events or signals like as needed, basically. So like the player will not be determining. We basically just want a filter or like a buffer that determines what kind of interaction is actually happening. That's why we're not going to do this on the character or anything else. Like you may have multiple things that want to interact with multiple things. I mean, who knows? If we're creating a modular system, we need to abstract and think about it in as generic a sense as possible. And there's really no other thing I could think to use besides an actor component in Unreal Engine for that kind of thing. And before we get started on the interaction manager component, let's go into our blueprints folder and create another folder called interfaces. And we are going to create a blueprint interface called Interactable. And we will, I like to prefix my interface functions with the if underscore, just so it's easily searchable. And I'm going to type get item data, or I guess, let's go. I've been using the naming convention item, so I'm going to change the interface to BPI item. And I'm going to if underscore get item data. And in the outputs, I'm going to create 3 outputs. And I'm going to make it of type the first one of type actor. I'm going to call it item ref. And make another one of type gameplay tag. Oops. And call it item tag. I'm going to make another one of type integer and call it item quantity. And while we're in here, I'm going to create another interface function called update overlay material, which I'll explain in just a second. And I'm going to create an input of type Boolean and call it activate ? And then I'm going to create one more function called on interaction attempted. And we may not use this one, but just to be safe, or actually if on interaction, cool. And this will be just so we can call like the interaction component we'll figure out what what it needs to do as far as like the larger, broader sense of the system. It'll figure out what needs to happen when you interact with something. But on an individual blueprint level, that blueprint may need to know what happens when the manager wants to interact with it. And with a function like on interaction, we can call that within the blueprints itself, the blueprints themselves, and edit it in every instance of the blueprint, basically. And so, speaking of this update overlay material, I basically figured we could make a system where in most games you'll be running around in the world, and as you approach interactable items, maybe they'll glow white just to illustrate that they are in fact interactable. And then once you get out of range, they stop glowing white. So I figured we would implement that just because I feel like that's something to that extent to indicate to the player that something is interactable to one extent or another is in almost every game. So let's create another folder called materials. Right click and create a material. I'm going to call it mm underscore highlight overlay. I'm going to double click it, and this will be a really simple material. I'm going to click right here on the material itself, material attributes, and go to translucent. I'm going to hold down 3 and click and create a color. Right click, convert to parameter, and call it color. I'm just going to make it white for now. I'm going to right click and type FRES and get a Fresnel. I'm going to hold S and click for a scalar parameter, and I'm going to just call it basically what these values are, and put the values in these parameters as what they are by default, which, yeah, okay. And I'm going to hold S and click for another scalar parameter and call it, I don't know, base reflect, whatever that means. Base reflect, and change it to 0.04. Boom, cool. And if we hold M and click, we can get a multiply, plug these up, and that's our Fresnel. Now we probably want this to be a little more noticeable than that on an item. So let's grab this Fresnel. Let's grab this color, plug that back in, opacity. Let's grab this color, get another scalar for emission intensity. I don't know, 20, change to 20 maybe, and then put that in emissive color. And actually we might need to grab this from here. Yeah, there we go. Excuse me. So if that makes any sense, just set that up real quick, and that will be our material we'll use for that. And I'm just gonna right click on it, create material instance, mi underscore white highlight. Cool. And now say you wanted different things to highlight in different ways. Well, now in any item that you would like, in any item you would like to know, or you would like to highlight, I guess, you can go into your data assets and create a material instance variable and just call it highlight or overlay highlight material. Bam. And then let's go into our items and implement that interface that we created for what implemented interface is item. And then we'll have these interface functions now. And on update overlay material, let's get the static mesh. Let's set overlay material. And out of new overlay material, we can just do a select. And based on whether we want to activate it or not, if it's true, we will get game item or get item data by tag. And we will do a Boolean for if the data is found. And if it is found, we're going to get this overlay material that we set and set it as that on the static mesh in here. And if it's not, we're just going to set it as nothing. And we just need to plug in our item tag from here, and then that will work perfectly. And you can see, kind of start to see the power of basically having all this data that you need for items stored, but just stored by basically text with a gameplay tag. And so instead of storing like all this data in multiple blueprints all around your game, you have one source of that data, and you really just need a string or a text variable to get it, to pull it and reference it. And I think that is a lot more efficient than most ways I see stuff like this done. And not to mention it if you keep this system up throughout the whole entire project, it kind of dictates that there is only one source of truth and you'll never get the wrong data because two of the same variables saved in totally different places don't match. Um, and so let's now that we have that, let's actually go into our interaction manager component, and we will, if you right click within an event graph and just type T dot, oops, if you right click and type T dot, you can get the add custom event um, instead of typing in custom event every time. But let's create a custom event with interaction manager called Interactables in range timer. And then we'll create timer or set timer by event, plug that up, and we'll create another event called Interactables in range tick. I'm going to change the time on this set timer by event to 0.01, click looping, and then promote the timer to a handle just in case we need to cancel it sometime or invalidate it. I'm going to call it Interactables in range timer handle. And then I'm just going to connect these delegates, and there we go. And then basically, whenever we call this, which we can actually create a Boolean for this and enable interactables in range tick, or let's say trace question mark, we can go to event begin play. And if this is true by default, then we will run interactables in range. We will run our timer. Now, most of the time you would put something like this on event tick, but I find it much easier to do something like this than event tick because you always have a means of canceling it or shutting it off. And I think it's much better and modular and scalable to do things like this. So let's set that. We'll set that variable to true by default so it runs, and think about what we need to do to let us know what interactables are in our range, basically. So let's create a function called interactables in range trace. And let's do a multi-sphere trace by channel. And this is basically going to do a sphere trace, and we're going to set the radius. Let's actually promote that to a variable and call it interactables in range trace radius. And by default, we'll set that to something like, I don't know, 750. And we just need to get our owner, type get owner, and then you can get actor location and plug that into the start and end. And let's create a Boolean, another variable for a Boolean called show debug question mark, and make that instance editable. And we'll change it to true by default. And off of our draw debug settings, we will do a select. And based on whether this show debug is true, we will promote the true to a settings to a variable called debug settings and make that instance editable. And we will just make that for duration for now and make show debug to true by default. And let's delete that. And we really want a multi-sphere trace for objects, and let's reconnect all our stuff. Because remember, we're thinking ultra modular, ultra scalable. And what we really want to do is we want to search for objects, right? And we'll say desired trace object types. We want to be able to set this, what objects we're looking for, depending on our project. So for instance, in this project, we can really just do all of them for now. And then later we can validate that it responds to the collision channel we're searching for the way we want. Now the interesting part is actors to ignore right here. Let's just create a function and call it get actors to ignore. And let's create an input of actor and call it additional actors to ignore. And I'm going to make this an array. Let's also create a local variable called actors to ignore local and change the variable type to an array of actors. And basically, I'm just thinking in games, you know, sometimes that you'll have items that are attached. Like typically we would just get the owner of this component and ignore that actor. But in some cases, you may have equipment on your character or things attached to your character or even additional completely separated actors that you also want to ignore from this trace. So we kind of need a, you know, slightly more complex calculation than just getting the owner of this component to decide which actors we all want to ignore. So I'm just going to drag this local variable in and type append array. And I'm going to append this array with this array. And then I'm going to get owner, get attached actors. And then I'm going to also append this array to this array. And that will basically, and let's actually return, and then we want, after we append this, we want to return this local variable, which should contain all the additional actors we plug in from the input, as well as all the attached actors that are on here that are, attached to our actors. So let's go back to our interactables and range trace, and we can drag off. Oh, we can make this a pure function probably. And let's make array. And actually we probably should add the owner to it by default. So let's do this and do this. Add unique. Get our owner and add it to our local variable of actors to ignore. And then we can return. And so now we don't have to add that on the trace function. There we go. So we have no additional actors to ignore. And we just want to do that. And that should work. Okay, cool. And so now after this, we're going to, and this is basically going to do, you'll see, I'll illustrate it more clearly in a second, but this is basically going to do a sphere trace from your character in this radius, which is 750, and it's going to return all the items that are of this object type, like collisionally, and then it's going to return all those. So we want to validate that it actually hits something and get this out hits array, which is just an array of all the hit results that this trace returns. And then we want to take the hit actor and we want to type get collision response to channel. I'm sorry, hit component. Get collision response to channel. And we want to make sure that the component we hit is responding to the interactable channel that the custom collision channel of type interactable that we set up earlier. We want to make sure it is responding to that channel by it being blocked. And also we want to make sure that this hit actor implements our interface, which was BPI item. And let's make a local variable of type actor, and we'll say interactables, all interactables in range, local. And so basically, if these conditions are met, we can add that actor to this array. Boom. And then we want to make sure we put a return node after completed, so it actually goes through all these and does this right here. Boom. All interactables in range. And we probably need a Boolean for whether or not there are any interactables at all. Let's say interactables in range valid question mark. And let's actually like to move these to the top. So right here, we'll check true. And then we'll duplicate that return node, put it right here and check false if it returns false. And we can go into our event graph now, and in our interactables in range tick, we can firstly do this. Boom. And we can do that. And just to make sure this is working, we can promote this to a variable, all interactables in range. And we will loop over these. And let's just get the class of actor that it is and print it and see what's going on. So if we hit play, yeah, there we go. So you see our actors were getting the right, it's hitting, it looks like it's hitting all of them because they have the red dot by them. Cool. So let's go and just to, where were we? Interaction manager. Let's actually let's promote this time to a variable and call it interactables in range timer tick rate and make that instance editable. And let's make that, I don't know, 0.1 by default, just to save some processing. Let's go. Let's make sure we put this instance editable too. And we're marking things that are instance editable. We want to mark them instance editable when the intention is kind of to change them, or like they are changeable. They're not just, internal variables that really shouldn't be touched. So let's actually duplicate this all interactables in range array, and we'll make another one called activated, overlay highlighted interactables. Cool. And so we can create a function for activate overlay highlights. Cool. And so we want to get our all interactables in range and loop over them. And we want to make sure before we turn on the highlight material, we want to make sure that it is not already turned on. We want to make sure it's not already turned on by doing this, which there's nothing in this array right now, but there will be in a second, which ultimately in this array is going to be every item that is in range and that we have turned the highlight material on already. So we're going to make sure that all the interactables in range, which we're getting every time this runs, which is 0.1 right now, we're going to get all the interactables in range, right? And we're going to set that variable here. We're going to get it from this function and set that variable. Now, within activate overlay highlights, let's activate interactables overlay highlight. There we go. That's a little better. It's really important to name your functions as descriptive as possible, and it can be hard to come up with names sometimes. Sorry. So yeah, so we get that array of interactables in range, and then we're just going to make sure that they're not already in our array of items that we've built out to contain which items that have the overlay highlight already, which may not make much sense, but give me 1 second. So if it is not already in here, then we're going to add it to here. But first, we are going to call our blueprint interface function of update overlay material. And we're going to activate it, and then we're going to add it to this array. And basically, so we're going to, every tick, we're going to go through all the interactables in range, and we're just going to get that variable. Okay, then we're going to go through each interactable in range. And if we haven't already added it to this overlay highlight interactables array, then we're going to turn the overlay material on and add it to that array. We're then going to deactivate interactables overlay highlight. And then we're basically going to need to do the inverse. So we are going to loop over these, which is all the items that we have that have their overlay material on. And we're going to see if they are no longer in our interactables in range array, which we are getting every tick from this function. So we'll do a contains not and connect that to our branch. And if they are not in our interactables in range, that means they are no longer in our interaction radius, in which case we need to update the overlay material to deactivate, to turn it off basically. And then we're going to remove it from this array. And so basically We can do a sequence after we set this variable, and we can activate and then deactivate. And hopefully that makes a little sense, but we're basically every frame, we are getting a new list of all the items that are in our interaction range. Okay. And then once we do that, we are first going to turn on the items, the new items in our interactable range, because the ones from the previous tick have already been turned on and have already been added to this array. And so after we activate all the ones that need to be activated, we then will go over the ones that are already activated and check if they're in this array. And if they are not, that means we have an item that has its overlay material turned on, but is no longer an interactable, in which case we need to deactivate it. The only other thing we need to do is, let's see, we'll say clear all interactables, or no, clear all overlay highlighted interactables. And this is just going to be what we're going to call if there are no interactables at all in our range. See, if we don't do this part right here, we will actually end up, every time there are no interactables in range, we will always have one item left that we still need to turn off pretty much. So we're just going to create a function that goes over all these. So we'll loop over all the items, because if we have no valid interactables in our range, this should be empty and all the items should be off. So we can update and deactivate it and remove it. Cool. Now let's give that a shot. And actually, just so we can see it better, let's turn off the show debug and see. Okay, let's get it out of range first. Wait, what was that range? Let's see. Let's go to the trace radius, 500 maybe. Did we set the data? Let's make sure we set the, yeah, we didn't set the material. Hold on. There we go. All right, so we're out of range and then we're in range. Boom. And I think that caret is lighting up because it's the only one that we set up these functions on. Yeah, so let's go see. Let's make sure. Blueprints, test items. We have a mushroom. Yeah, it's the only one we did. So let's add our interface. And remember, we're doing it this way. Like typically you would have all these items in some kind of file structure to where you would only have to do it once. But we want to try to use this system on every game, every project moving forward. So we really want to take into account that there may be blueprints all over that we need to share functionality for. And so that's why we're kind of doing it like this. So event if update overlay material, we will get the item mesh and set overlay material. We will do a select. And based on whether or not we want to activate it, if we will get the item tag and get, here we go, get item by tag. If it actually has data for it, we will get our overlay highlight material. And so if we want to activate it, it's true. If we don't, nothing. And let's go to our Steam Veggies, go to class settings, implement this blueprint, update overlay material. We will get the the item mesh, set overlay material, pull off the overlay material, select. And in our select, we will drag the activate, get item data by tag, get our tag. If this is successfully found, we will set our overlay material. Get overlay material, true. And let's see. There we go. They're all highlighted. There we go. As we leave, they do that. Cool. So that's working. So basically, remember that was just simply to highlight all interactable items basically that are in our range. And that part is pretty much done. So we can just comment this, highlight interactables in range, timer / tick. Boom, got that. And we can actually throw these functions in a category. Interactables in range. There we go. Got it. And let's see what we got. Where were we? We were in the items. I was going to, yeah, let's set up this get item data before we move any forward in each one, which is just another interface function that we created. And off the item ref, I'm just going to get a reference to self, and off the item tag, I'm going to plug these in. Item tag, and item quantity, and I'm going to do that to everyone. Let's see. Get item data, reference to self, item tag, item quantity. Cool. All right, so now that we have all the interactables in range, we can actually try to interact with these items. So let's create a function for try interact with item. And let's think about this. So we have all the interactables in our range right here. We're going to have that every tick basically. And so we need to do some kind of delineation on which one to interact with, assuming there are multiple items to interact within our radius, which I'm sure there sometimes will be. The way most people would do this is by running a bunch of traces and calculating the distance and angle and stuff by doing line traces on tick and stuff. But that can really stack up, and there actually is a smoother and better way to do it with just some simple math. I mean, quote unquote simple. The first thing we can do is get the dot product of the direction of the, so basically in relation to our player character's forward vector, we can get the dot product of the direction that the item is in relation to the player's forward vector, and then that will give us the angle at which the item sits in relation to us. If I know that was extremely convoluted, but if it doesn't make sense, we can basically, what I'm saying is we can basically run a dot product calculation to get whether the item is more behind us than in front of us, okay? Because we don't want to highlight things that aren't on the screen. So we can do that to just get what's most in front of us, basically. And then, or I guess not most in front of us, but we can just get a list of what is actually in front of us. And then we can delineate by distance to see what is in front of us, but also closest to us. And I think that's the probably most generic way to do it. In some cases, you would want to interact with stuff that's behind you, but it's really close, for instance. But I think we're going to do it this way, which is probably the safer way. Just so that, players only interact with stuff that they are actually facing, if that makes sense. So they don't accidentally interact with stuff that is behind them. So let's start with that. So we're going to we have our try interact with item, which is the function we're going to call on the player when we actually try to interact with an item. So we're going to need some helper functions for that. And we're going to say filter interactables by dot. And let's create a variable for interact FOV. Float, let's say cutoff. And we'll make that instance editable. And I'm going to put 90 because that's, 90 should be about, all the way left or all the way right. If anything is past that point, all the way left or all the way right from the player, then it'll be considered behind us. So let's drag in our interactables in range. And let's actually create a local variable. Wait, we don't need to. Yeah, let's actually create a local variable of type actor and an array of actors and call it dot filtered interactables local. And we'll drag that in. And first thing we're going to do is we have on every frame that we're running our interactable trace, we're going to have a valid list of all interactables that are actually in our sphere radius of whatever we set right here. Okay, so to filter by dot product or by, direction, we're going to basically get the actor location that is in, every interactable in range. We're going to get that actor location and compare it to, we're going to subtract it from our owner's location, and that will give us basically a direction vector. So by getting not the distance, sorry, we're going to subtract these two, and then we're going to normalize, which basically takes a vector and gives it and shrinks it to a magnitude of 1, which, for all intents and purposes is a direction. So now that we have a direction, we need to do a dot product comparison on it. And we want to compare it with our owning character, the owner of this interaction manager component. We want to compare this direction we got with this direction, if that makes any sense. Like this, the subtract, I'm trying to explain it. It's kind of complicated to explain, guys. Bear with me. But subtracting these two actor locations basically gives us a direction that the item is in relation to our character, basically, for instance. So it's going to give us a 45-degree line pointing to the item. And the dot product is then we're basically going to compare that line to the product, to the item, with the line for our forward vector. And based on what the dot product returns, will determine, it will basically give us it's very hard to explain, but basically we're running this calculation to get the angle at which the item is from us, more or less. So this is going to give us a number between -1 and 1, which is kind of usable. But to make it even more usable, we can type in, wrong one, sorry. We can type in acos degrees, and that will change the -1 to 1 that the dot product function gives us to an actual like -180 to 180 degrees, like rotation degrees. And then we can drag off that and type in absolute, because we really don't care. Like how it does this calculation is, if it's to the left of you, it starts going negative, and if it's to the right of you, it starts going positive. So for instance, if this returned like that, the item was directly to the left of us. I'm sorry, not this absolute one. If this acos, if it would return like -90 if the item was directly left to us, and +90 if the item was directly right to us. And and it gets very confusing and not very usable, because what weighs negative, what weighs positive, we really just need the absolute value of that. We don't really care if an item is 145 degrees to the left or right. We just care that it's 145 degrees from our forward vector, which means it's behind us. We don't really care if it's left or right. We just want the actual number. So this absolute will take off the negative if it exists. So the value will always be positive. And we just need to know if this right here is less than or equal to this variable right here, which we set to 90. And if it is, then we can say, okay, this item is more in front of us than behind us. And I say it's more in front of us than behind us simply because this is 90 degrees. If this was 45 degrees, it would just mean that the item is less than 45 degrees. It's inside 45 degrees from the point of view of the player. So it is not outside of a 45-degree angle. And if that is the case, we're going to add it to this array. And then at the end of all this, after we've looped through all that, we're going to just return this array. And before we should, just for safekeeping, we should actually just clear this before we do all this. Boom. And we can actually, surprisingly, we can make this a pure function, I believe. So I know that was probably the most complicated thing to explain ever, but I hope it made a little sense. And the reason why we're clearing this at the beginning is because this may end up stacking. For instance, if we run this a couple times, like this array right here may end up having the same ones from the last time this function was run, or 10 times ago this function was run. Every time this function is called, we want to start from scratch with a fresh list of actors and nothing already in that array. That's why we're clearing it before we do the loop. So if we go to our try interact with item, we can drag in this, and it's really crucial to me to do stuff like this. Like we could have obviously done all this within this try interact with item function, but it gets extremely messy and not readable or editable at all. And remember, we want to try to use this on every project. So it's important that we keep it clean and our line of thinking can be followed clearly. That's why I struggle and kind of hesitate with the function titles, because that kind of stuff is just so important if you ever want to reuse these things. So after we filtered interactables by dot, we really want to we want to get target interactable by distance. And basically we're going to take the list, the list that this provides, and we're going to filter them. We're going to find the thing that's closest to us, basically. And so at the end of all this, it's going to give us the item that is inside our cone of vision and closest to us. And that's the item we're going to target to interact with. So as input, let's put actor. Let's make it an array, and we will say dot filtered interactables. And we're going to need a couple local variables, which one is going to be temp distance. And I'd like to put the local. And before we run the loop on this, we're going to set this to 1,000,000, which it really just needs to be a super high number. And you'll see why in a second. And then we're going to create another local variable of type actor and call it target interactable. And we're going to invalidate this before every time we run this function as well. And we're going to loop over all these items that are coming in from this filter interactables by dot. That's going to get us a list of everything inside our vision. And then this one is getting that list. And then we're going to go through it and get the closest thing to the player. So if we pull off that actor array element, we can get the actor location and type distance. And then we can get our owner of this component, which is going to be the player, and get that actor location and put it in there. And now we will have basically like this, the dot filter was getting the direction, and this is basically going to get the magnitude. So this is just going to get how far we are away from each other, the item and the player. And we want to see if this is less than or equal to this distance right here, which is 1,000,000. So, and we know that to even get in this list, you have to be within. So actually, we don't need to put this to 1,000,000. We could just put this to this right here, this interactables and range, interactables and range trace radius, because we know nothing that this array ever gets will be outside of that, because that is the distance of our trace. And so basically, we're going to, once we get the distance of every item that is in our range, so it's going to go through every item, carrot, mushroom, and it's going to say, what's the distance from the player to this item? It's going to say, is it less than or equal to 500, which some will be, one will be at least. And if it is, then we're going to promote this to our temp distance. So basically, we get a baseline. We get the initial baseline from our trace radius, and then the minute we find something that's less than, that becomes our baseline. So the distance between our baseline is 500 from the trace radius variable, but the mushroom is 450 away, not 500. So now the mushroom becomes what we compare all items to, but the carrot is 300 away. And so now the carrot is what we compare all items to. And then the steamed veggies are 150 away. Okay, that is the new target interactable. I hope that makes sense. That was a little easier to explain than the dot product stuff. And so basically, we're going to set this distance to this item. So it's going to go through, it's going to set it, it's going to replace this temp distance, and then it's going to go through and replace it every time it needs to. And every time it does replace it, that means that item is the closest thing so far to the player. And in that case, that is our target interactable. So during this loop, these things might get set a couple times. And so we're going to return, after it goes through all those actors, we are going to return the target interactable. Boom. And that is going to be it, I think. And we can actually make this pure function. Okay, we already did. And that will basically give us the item that is inside our interactable trace range, that is in front of us basically, and that is closest to us. Boom, easy peasy. And we can drag off of that and type is valid. And actually, now that I'm thinking about it, let's go back to our event graph. And inside of these functions, these loops that we did, we're going to actually, it's always good to do this, guys, or you'll get a lot of errors because there's going to be cases that we want to delete an item. We want to destroy an actor when we interact with it. And there's going to be some cases, some edge cases that it tries to loop through something that is in here that we've already deleted. So we only want to continue with all this other stuff if the item we're going through is actually valid. So I'm going to go to all these and validate before we do anything else. Let's see. All right, now we're in our try interact with item. We have our target interactable, which is the individual actor that we're trying to interact with. And we are basically going to drag off of this and just type if get item data. And that is going to be our interface function for all the stuff we need. So for instance, let's see if we can say, let's see right here. So let's go to our components. Let's go to item container. And just to illustrate this, let's create a new function for try add item to inventory. And let's create our inputs for actor. We probably will not need the actor reference for this function, but we have it from the interface, so we might as well, but I doubt we'll use it. Gameplay tag, so item tag, integer, item quantity. And for debugging purposes, let's just drag off of this item ref and get the class that it is and print it. There we go. And interaction manager component, we have this game item data. So we're going to get item data by tag, right? We're going to validate that this data asset is actually associated with an item tag. Or I'm sorry, that this item tag that we're pulling from this actor is actually within our data table and has a valid data asset. And if it does, we're going to get the interaction event tags. And now we can see what exactly we want to do. So for instance, we can say has tag, and we can see, hey, does this have the interaction or the add to inventory tag in its event in its interaction event tags? And if it does, let's actually go to blueprints. No, I'm sorry, go to our folder, blueprints, interfaces, go to blueprint and create an interface, and we'll say let's say get interaction and inventory components. And we'll say if get interaction component, if get item container component. And this will be how we're going to basically get the item container component reference that is in our character. So item container component. Now, this is not necessary because, for instance, in our interaction component, we can get the owner, which is our player, and we can just get component by class to get the reference to our item container that is in our player. But I really lately have liked doing things this way by just creating an interface. I just find it much simpler. I just find it much simpler to do that. Let's actually add it to item one. Yes. Class settings. Here we go. BPI, get interaction and inventory component. And that will basically just serve to get for now, it'll be just to get our reference. I'd much rather just call one function than getting the owner, getting the component by class and validating it and all that. So that's why we're going to get this. We're going to get owner, and then we're just going to type if get, and here we go. If get item, get item container component. And so if we want, this will give us the reference to the player's inventory basically. Or I say the player, but the owner of this interaction component could be player, could be whoever. So if inside this data asset that is basically inside our target interactable, if the interaction event tags contain an add to inventory tag, we're going to add this item to the we're going to try to add this item to the inventory. And these are just these right here. Boom. Gotcha. And then we will, and I think that should be it, honestly. Let's see if this is going to work by going to our third person character in the event graph. Actually, we can create another graph and call it debug graph. Or actually, let's call it input graph. Right click IA. Remember we created that IA interact. Drop this down, and from started, we're just going to get our interaction component and try interact with item. And if we hit play, go here, carrot, steamed veggies, mushroom, boom. So that's working exactly how we want it, to be honest. I think that I'm just thinking modular. Remember, ultra modularity and scalability. Let's think about this for a second. So the first thing we're going to want to do is check. So we can do it like this. We can definitely do it like this. Or I'll show you one more way to do it, which we can do both in this case, actually. I'm going to leave this for now. But we can also, which may be a more modular way to do it, but it's actually, I don't know. I'm going to keep it like this. And then we can also do this on interaction event. And let's create an input of gameplay tag container, interaction event tag. And if you notice, I just snuck a sequence in here right before this. And we are basically going to call this. Actually, let's not do an event dispatcher. Let's just create it in our blueprint interface. Sorry, BPI item on interaction. Let's change that to on interaction event and add an input of gameplay tag container. And let's see, interaction event tags. We can say, because there's going to be some interaction event instances that we want to just handle in the interaction component, but there's also going to be some that we can handle within the blueprints themselves. So for instance, where is that? Let's get our valid interactable, which is just this actor actually, and type BPI. No, sorry. Here we go. On interaction event. And then we will just get these tags and put them right there. And now inside our items, we can go to on interaction event and we can say if these tags that are being called have destroy after interaction, then we want to destroy the actor. Which one was that? That was the carrot. There we go. And we get no errors or anything. This is working pretty perfectly. And you can kind of, I think this is good enough for now. This system is good enough for now I think the system is good enough for now to do this, but we maybe expand on this or maybe clean it up a little, figure out a better way to call the events, but I really like this for now. So you can keep it like this. And I think it's definitely more, I'm thinking about it in a way that like typically you could just check if this event tag has the destroy interaction and destroy the actor from the manager. But there's going to be situations in which we just want to call an event on the target interactable. So this is a good way to do that, do both kind of, or at least set up the functionality to do both. And so basically let's make a return node here because there may be some instances in which some other external system needs to know if the interaction was successful. So let's just say interaction. And at the end of both of these, actually, let's not put that there. Let's create a third sequence pin and just end it right there with the, so we go through all this. We're just going to put a return node for false on every branch, just in case it fails, or if this thing is not valid. There we go. And if we go into our third person, we have interaction successful. Cool. And I'll tell you what, just before I end, I'm going to end the video here, and we'll pick up with the inventory systems, the component, item container component, as well as all the visual aspects in the next episode, which will be out this week or next. But I want to show you something real quick, that just to show how we can, just keep extending on this system. And if the bare bones are there and clean and thought about in the right way and implemented in the right way, you can really, there's nothing you want to try to not do anything that will prevent you from doing something in the future. And the only way to do that really is to separate concerns as much as possible. So in our item blueprint interface, we can create another function called can interact ? And we can create an output boolean as type boolean and call it can interact ? And within our, for instance, mushroom, we can create a boolean for the same thing, which is can interact ? And here we can say can interact, and we can put that in here, and let's leave it false by default, because like I said, we want to try to use this in every game, every project. So we want to make it universal as possible. So basically, there's going to be maybe some instances where you want the ability to set whether or not an item can be interacted with, based on some kind of setting or information or state that is active in the game right now. And an easy way to do that is just with what we just did, creating that boolean, because now we can say, can we interact? And if we can, true. But if we can't, then we failed to interact. And so let's do that, and then we can go into our can interact. Let's create the boolean and all our other test ones can interact, but we'll put it positive for those. We'll put it positive by default. So what is it? Our mushroom, we left false by default. Can interact, we'll say can interact. Plug it up, compile, and we'll put that as that. So let's see. So if we go up to here, we can interact. We can't interact. Wait, what? Mushroom, steamed veggies, Q. So if we can't interact. Oh, I was like, wait, what? Well, but we didn't destroy the interact. I'm thinking it didn't interact right because it wasn't destroying itself, but we only did the destroy in the carrots. So yeah. So we have the carrot. Yeah, that successfully interacted because the name popped up in the top left, and we can't interact with the mushroom. Let's, just to make this more evident that it's working, hold on. On interaction event, has tag. If it is destroy after interaction, exact match, we will destroy the actor, which is self. So let's see. Boom. Successfully interacted. Oh, can't interact. So hopefully that illustrates the power of this scenario, the power of this system, and that, and it's only going to get more and more modular and expandable and scalable. And hopefully, like I said, my goal with this series is for us to create the last interaction and inventory system we will almost ever need to build for our day-to-day projects. There are new projects that are new prototypes that we're testing, things like that. And my goal with this series is to take it even further than that and make it, a whole game, many game systems that we can, learn a little bit, implement, and reuse most of it. So that's going to wrap it up from here. Like I said, then in the next episode, we'll go over the inventory system and the visuals for the inventory system and just keep going from that. Appreciate you guys for watching. Check y'all later. Thanks.